Hello everyone, myself Vinay Kumaram. I am pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my previous video, I had explained about exercise 7.2. So after exercise 7.2, you have few more concepts in this particular chapter that I will be teaching in this particular video. So now, after solving questions in exercise 7.2, we have two more theorems, that is theorem 7.4 and theorem 7.5. So now we will look into the theorem 7.4. So in theorem 7.4, here this particular theorem 7.4 is also known as SSS congruence theorem. So this particular theorem 7.4 is also known as SSS congruence theorem. And here, if you want to prove this particular theorem, you have to practically prove this particular theorem. So now, first let me write the statement of this particular theorem. If three sides of a triangle, of one triangle are equal, so if three sides of one triangle are equal to the three sides of another triangle. So if three sides of one triangle are equal to the three sides of another triangle, then those two triangles will be congruent to each other. Then the two triangles are congruent. So all three sides of one particular triangle, if it is getting equal to all three corresponding sides of other triangle, then those two triangles are congruent with each other. So how to prove this particular theorem? So you can just take one particular scale and you can draw 7 centimeter line, or whatever you have in your mind, you can take that value. So now I am considering 7 centimeter and I will draw one more line which is 8 centimeter. And I will draw one more line which will be equal to some 8.5 centimeter. So now if I have this particular triangle, so in this fashion only you should write another triangle. So in another triangle, you will write this side as 8.5 centimeter and you will draw this side as 7 centimeter and this will be 8 centimeter. So if you draw exactly like this two triangles, then take a protractor and measure the angle which is there between this 7 centimeter and 8 centimeter side. So that will be exactly equal to this particular angle on the other triangle which is there in between 7 centimeter and 8 centimeter side. Now you measure another angle which is there between 7 centimeter and 8.5 centimeter. And here also you measure the angle between 7 centimeter and 8.5 centimeter. So these two angles will be equal to each other. Similarly, you measure the angle between 8 centimeter and 8.5 centimeter of one triangle and measure the angle between 8.5 centimeter and 8 centimeter of the other triangle. You will notice that this particular angle will be equal to this angle will be equal to this angle, and this angle will be equal to this angle. So that means if you have two triangles where all the corresponding sides of two triangles are getting equal to each other, that is all three sides of one triangle is getting equal to the corresponding all three sides of another triangle, then those two triangles are congruent with each other. So here, if you take a protractor and measure the angles, the corresponding angles will be equal to each other. So that means here all the sides and all the angles, that is all the respective sides and all the respective angles of two triangles are getting equal to each other. So that means these two triangles are congruent with each other. This is how you can understand this particular theorem 7.4. Similarly, we'll go to the next theorem, which is theorem 7.5. So theorem 7.5 is known as RHS congruence. So theorem 7.5 is known as RHS congruence. So in RHS theorem, what RHS theorem states is that if in two right angled triangle, so if in two right angled triangles, here if the hypotenuse and one side of one triangle, so hypotenuse and one side of one triangle is equal to the hypotenuse and one side of another triangle are equal, another triangle are equal, then those two triangles are congruent. Then those two, so then those two triangles are congruent. So that means here you have to consider two right angle triangles. So let me draw two right angle triangles like this. So one is triangle ABC, where angle B is equal to 90 degree. And I will consider one more triangle like this. So I will consider one more triangle like this, which is named as PQR. And here Q is equal to 90 degree. So now if AC is equal to PR and any one side, let's take AB. So AB is equal to PQ. Then these two triangles will become congruent to each other. So that means if angle B is equal to angle Q is equal to 90 degree, and if hypotenuse, that is AC, you should consider hypotenuse only. So if AC is equal to PR, and you have to consider one more side, that is any one of the side apart from hypotenuse, that should also be equal to the corresponding side of other triangle, other right angle triangle. So here AC is equal to PR, PQ is equal to AB. So if this is the case, then these two triangles will be congruent with each other. So that is what this particular RHS theorem states. So now based on these two theorems, we have two examples. So we'll solve those examples here. So now we will solve example 7. So in example 7, you have a figure like this. So you have a particular figure like this, where this particular diagram is named as P, A, Q, B, and this particular AB is joined and this particular PQ is joined, and this intersection is named as C. Here this particular side is equal to this side and this side is equal to this side, that is AQ is equal to AB, QB, and AP is equal to PB. So here AP is equal to PB and AQ is equal to QB. So now you have to show that this particular PQ is perpendicular bisector of AB. That means here this angle, this angle, this angle, this angle all should be equal to 90 degree, and this particular AC. So what we need to prove is we have to prove that PQ is perpendicular bisector of AB. So that means it bisects AB in such a way that AC will be equal to CB. So that means here we need to prove AC is equal to CB, and we have to prove that ACP angle will be equal to BCP angle, which is equal to 90 degree. So that means these two angles we have to prove they are equal to 90 degree, and we have to prove AC is equal to CB. So now we will try to solve this. First we will consider these two triangles. So first we will consider these two triangles like this. So now we will consider these two triangles, that is APQ and PBQ. So APQ APQ and PBQ. So now we have these two triangles. Here you have to prove these two are congruent triangles. So now we know that AP is equal to PB and AQ is equal to QB, which they have already given. So consider here, consider triangles AQP and triangle PBQ. So here in these two triangles, AP is equal to PB and AQ is equal to QB, because these two things are given, already given. And here PQ is equal to PQ because it is a common side. So PQ is equal to PQ because PQ is common side. Now according to SSS congruence, so here therefore according to SSS theorem, so according to SSS theorem, triangle AQP is congruent with triangle PBQ. So now if these two triangles are congruent, then this particular angle and this particular angle will be equal to each other. That is here APQ will be equal to BPQ because triangle APQ is congruent with triangle PBQ. So since these two triangles are congruent, these two angles will be equal to each other. In the place of writing APQ, I can write APC also because C lies on the PQ line. So in the place of writing Q, I can write C. Here in the image you can see, instead of writing APQ, I can just end it at C because C is lying on the APQ, C is lying on the PQ line. So in the place of taking APQ, I'll just take APC. That is this particular angle we have proved equal to this particular angle. So here in the place of APQ, I can write APC. So or APC is equal to BPC. So let's call this as equation 1. Now consider triangle. So now let us consider triangle. In this we will consider this particular triangle. So we'll consider this particular triangle and we'll consider this particular triangle, that is APC and PBC. So consider triangle APC and triangle PBC. So here in these two triangles, you can see already in the data they have given AP is equal to PB. So here they have already given AP is equal to PB, which they have already given. So now we'll just write the triangles one more time here so that it will be easy for us to understand. So this is P, this is C, this is A, and this is B. So in APC and PBC, AP is equal to PB, which they have already given, and we have proved that this particular angle is equal to this particular angle, and PC is the common side for both the triangle. So here APC is equal to BPC, which we have already proved, and here PC is equal to PC because the PC is a common side for both the triangle. So that means here triangle APC, so triangle APC is congruent with triangle PBC. So since triangle APC is equal to triangle PBC, here therefore AC will be equal to, this is according to SAS postulate. So you have to write that also here, according to SAS axiom. So according to SAS axiom, triangle APC is congruent with triangle PBC, and here AC will be equal to BC since triangle APC is congruent with triangle PBC. So since AC is equal to BC, therefore PQ bisects AB. So now we have proved that PQ bisects AB. We have to prove that PQ is perpendicularly bisecting AB, because we have to prove PQ is a perpendicular bisector of AB. So that means here these two angles we have to consider. These two angles we have to consider, which will be equal to each other. So here PCA angle is equal to PCB angle. So that means these two angles PCA and PCB are equal to each other, because this you can write in the bracket, because triangle APC is congruent with triangle PBC. So now since AB is a straight line, since AB is a straight line, here angle PCA plus angle PCB will be equal to 180 degree. Since AB is a straight line, so you can write in the bracket, because they both are linear pairs, because AB is a straight line. So now we also know PCA is equal to PCB. So in the place of PCA, I can write PCB only. So PCB plus PCB is equal to 180 degree. So 2 PCB will be equal to 180 degree. So this 2 you can bring to RHS, that will go to denominator. So PCB will be equal to 180 degree by 2, which will be equal to 90 degree. And we know PCB is also equal to, so here we know that PCB is also equal to PCA. So PCA is equal to PCB. So PCB is equal to 90 degree is equal to PCA. So that means therefore PQ is perpendicularly bisecting, or you can write PQ is perpendicular bisector of AB. So this is what they have asked to prove, and we have proved that. So now we will look into the next example which is there in this particular chapter, that is example 8. So in example 8 also you have one particular figure. So there is 3 straight lines given like this. So one straight line is passing like this, the other straight line is passing like this, and one more straight line is passing like this. So all these 3 straight lines are intersecting at point A, and there is a point P on this particular line which is equidistant from this particular line, and it is also equidistant from this particular line. So this line is named as L and this line is named as M. So point P is equidistant from L and equidistant from M. So that means you have to take perpendicular line from L to P, and if you take perpendicular line from M to P, then these two sides will be equal to each other. So this point is named as B and this point is named as C. So since P is equidistant from L and M, here this particular line is equal to this particular line, that is PB is equal to PC. So that is what they have given in this particular question. So PB is equal to PC, and here angle PBA is equal to angle PCA, which is equal to 90 degree, because we are calculating the distance from line. So whenever you are calculating distance from line, you have to take the perpendicular line from that particular line. So that means if you are measuring the distance between P and L, you have to take the perpendicular line, because perpendicular line will be the shortest distance between P and L, and also perpendicular line will be the shortest distance from P and M. So that's why here this angle will become 90 degree and this angle will also become 90 degree. So PBA is equal to PCA is equal to 90 degree. Now you have to prove that this particular angle is equal to this particular angle, that is PAB is equal to PAC. So now consider triangles PBA and triangle PAC. So that is this particular triangle and this particular triangle. We already know that PB is equal to PC. This is already given. And here PBA is equal to PCA, which is equal to 90 degree. This is also they have already given. And here, so I'll write this one more time in new slide. So PB is equal to PC, PBA is equal to PCA, which is equal to 90 degree. So both of them are given already. And here PA acts as common side. So here you can see PA acts as common side. So since these two triangles are right angle triangles, here you can see one angle is equal to 90 degree in both the triangles, and here PA acts as the hypotenuse of these two triangles. So PA is equal to PA, which is common side. So here PA is equal to PA, which is common side. So this particular PA is the hypotenuse. This particular angle is 90 degrees, so that is right angle, and this particular one of the side is getting equal to each other. So that means according to RHS theorem, so therefore according to RHS, R means right angle, H means hypotenuse, S means other than hypotenuse, two sides will be there, no, in that one side. So right angle, hypotenuse and one side. So according to RHS theorem, here triangle PBA, so we have considered triangle PBA and triangle PAC. So triangle PBA is congruent with the triangle PAC. So since triangle PBA is congruent with triangle PAC, these two angles will be equal to each other. Therefore, PAC is equal to, so here PAB is equal to PAC. So PAB is equal to PAC. This is because triangle PBA is congruent with triangle PAC. This is what they have asked to prove, that is angle, this particular angle A will be properly bisected by that particular line AB. So here you need to prove that this particular line AP, so this particular line AP exactly bisects the angle A. So here we have proved that PAB is equal to PAC. So that means here AP is bisecting angle A. So this is what they have asked in this particular example to prove, and we have proved that. So this is all there in this particular YouTube channel. Only exercise 7.3 is remaining in this particular chapter, which I'll be covering in my next video. Until then, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.